Hello everyone. This is a continuation of the topic integration. In this one we will be learning exponential integration and integration of trigonometric functions. Okay, so if you remember, you can relate to the differentiation as well as I'm writing down these integrals. So the integral of sine x will be equals to negative cos x plus c. The differential of cos x was equals to negative sine x. That's what I'm talking about when I say they're opposites. The integral of cos x dx will be equals to sine x plus c. And the integral of sec square x dx will be equals to tan x plus c. Okay, let's begin with some questions. The first question over here is this. You can remember these things and let's start. This will be sine 2x. Let's find the integral of this dx. So what you have to do over here is you will change the integral, the trigonometric function, which will be negative cos 2x. Nothing happens to this over here because this is an angle and this does not change. Okay, and then what you'll be doing is you will be dividing it with the differential of this. So the differential of this is 2. So this is what you'll be doing. And a plus c. This is your final answer. Let's do this one now, which is 1 plus sine x. This is an easy one. I'm just telling you the concept over here. So the concept is that 1 becomes an x in when you integrate something, the constant becomes x, and sine x is negative cos x. So there's a 1 over here if you differentiate this. 1 divided by this is nothing, so that's why I'm not writing it down. So this is your final answer. Alright, let's move on to the cos. So integrate 3 plus cos 4x now. What do you have to do? You just add an x to the constant and you change the sine 4x divided by the differential of 4x, which is 4, and a plus c. This is your final answer. Okay, how about tan now? So tan is, I'm confusing you in this one. So I want you to think for a second how to do this. What you'll be doing over here is that you can see earlier I told you that there's no integral of tan. Only integral is of sec square x, which gives you tan x. So what do you do now? You have to change this somehow into sec square. So if you remember the trigonometric identities, so there was an identity which was tan square x plus 1 is equal to sec square x, which means that tan square x is equals to sec square x minus 1. The only reason why I am doing this is because I want a sec square x in my question so that I can integrate it. This will become 3 plus sec square x minus 1. I can simplify this. This will become sec square x plus 2. Now I have to integrate this with respect to dx. Okay. Let's integrate this. Sec square x will become tan x. 2 will become a plus 2x and we have a c. Simple. You see how simple these are. Okay. Now let's add something to it. You have to integrate cos 3x plus 1 with respect to dx. The same thing will happen over here as well, which is that you first change this, the function. This is the integral of this. Nothing happens to this. Do not forget that. And you need to find the differential of this, which will be 3. And you simply divide it with this. Write a c and you're done. Let's do one more. We have 4 sine 2x plus 3, for example. Okay. What will you do over here? You won't do anything with 4 right now. You will first change the sign. Sign is negative cos. That's why I wrote a negative 4. Nothing happens to 2x plus 3 and divide it with the differential of 2x plus 3, which is 2. Now we can simplify this. This will become minus 2 cos 2x plus 3 and a plus c with it. Alright, let's add limits now. So when I add limits to it, let's take this question. We have pi and we have a 0, okay? Let's do this. 2 cos 4x with respect to dx. Okay, first integrate cos. So cos will become 2 sine 4x divided by 4. We can simplify this by writing 1 over 2, or we can simply just cancel it out. We can write sine 4x divided by 2. Now I need to add my limits. So why am I not writing a c? Because we have limits and it will cancel out automatically. Okay, let's add the limits. Use your calculator and just simply do it. Divided by 2 minus sine 4 times 0 divided by 2, and your final answer will be 0.108 from here minus 0 from here, which gives you 0.108. All right, let's bring in the exponentials now. So exponentials are, we have e now. So if we integrate e to the power of x with respect to a dx, we will get e to the power of x. Now what is happening over here? Basically, you just simply write this down first, and then what you do is you find the differential of this. So the differential of x is 1 and divided by this. So you can see that you cannot see the 1 over here, but basically it's being divided. That's why it's a simplified version of it. Let's do this. So integrate e to the power of 2x with respect to dx. Like I said, write this down first and then divide it by the differential of this and a plus c. This is your answer. Similarly, if we have, let's change the color. Okay, similarly, if we have e to the power 3x plus 1 with respect to x, we will first write this down, the same thing, and then divide it by 3 and a plus c. Easy. How about this? We have to integrate 2e to the power 4x plus 1 dx. So what you'll be doing is you will be just writing the same thing down, divided by 4 plus c. We can simplify this by writing a 2 and a 1. So there will be 2, 1 times 2, and I'll just adjust it over here only. So we have a 2 over here. Alright, this is all that you need to know. I just wanted to mention a few extra things that you will face when you're doing the past papers, which are that the integral of 1 over x can be written as ln x. Now, when do you get these questions? For example, the question is, let's say 2 over x. I want to integrate this, okay? So what I'll be doing is I'll be breaking this into 2 times 1 over x. This is how I'll be breaking it, okay? Then I'll be just writing 2. When I integrate this, this will become 2 ln x. This is your final answer, okay? So there will be a lot of questions when you face things like this. You won't find this in the book. I'm just telling an extra information over here. Also, there's one more thing, which is that when you integrate ln x with respect to x, what you get is x ln x minus x plus c. I'll be doing some questions of this in my next video where we're doing area under the curve. Alright, I hope it's clear. Please let me know if you have any confusion. Thank you very much.